Okay, so for cotangent, a lot of the things that we learned with tangent apply. So remember, where is it? Here, on this slide right here, we have a quick comparison of tangent and cotangent. Tangent goes through the origin. Cotangent has a vertical asymptote through the origin. Tangent is always increasing as you move left to right. Cotangent is always decreasing when you move left to right. Those are about the only differences. They both, from the middle point, they both, a quarter of the period to the left or to the right, you have a vertical change of 1, just like you did in tangent. So let's get to cotangent. So a cotangent will have vertical asymptotes every period, just like tangent did. The period is again pi, for the similar reasons for tangent. But where tangent went up, cotangent is going to go down. Cotangent will naturally be falling. And the key ordered pairs, you'll always have one in the middle that'll be on the midline. You'll have one, the other two key ordered pairs are a quarter of the period through, and they are vertically 1 away from the center, either up 1 or down 1, depending on where you are. Now, all that can change based on transformations. For example, 7 times the cotangent of x will look just like what you see here, except instead of going up 1, you would go up 7. So a quarter of the period over, you will be going up 7 instead of going up 1. The asymptotes naturally occur at 0 and pi. So if you want to find 2 consecutive vertical asymptotes, you would take what is affecting the domain in between 0 and pi and then solve for x. So let's practice. This example, I've got lots of, actually, we're going to do one example. So how do I graph this? There's lots of things going on. First of all, recognize that it's a cotangent graph, so it's going to look something like that. The cotangent graph falls. From left to right, it's going down, down, down. And the a value is 4, so it's going to be a little thinner than it normally would be. But it's still a positive 4, so cotangent still goes down, like the parent function. The +2 is the new midline, but neither the 4 nor the +2 affect the vertical asymptotes. And the vertical asymptotes is where I want to begin when I graph this. So let me first find these vertical asymptotes. So for cotangent, they naturally occur at 0 and pi, but this x over 2 plus pi is going to alter that. It's going to move it left or right. We know it's going to move it left because it's plus pi. And then the b value is a half, so the period also changes. So I want to solve for x. So I'll subtract pi. And then that gives me negative pi is less than x over 2, which is less than 0. Then I'm going to multiply everything by 2. So I get negative 2 pi is less than x, which is less than 0. So these two numbers, x equals negative 2 pi and x equals 0, are consecutive vertical asymptotes. That's really going to help me. Plus the fact that all other vertical asymptotes occur just a period away. So what is the period here? The period is pi divided by a half. So the period is 2 pi. So I know 2 vertical asymptotes. I can find many, many more. I just have to add 2 pi over and over and over again. The phase shift. It is not left pi. That's a common mistake. X over 2 plus pi, the b value and the horizontal stretch and the horizontal shift got mixed together. You have to factor out that b value. So pi divided by a half is 2 pi. So the shift is to the left 2 pi. So that's a lot of information right here. Let's go back and just review what it's supposed to look like. The parent function is going to look like this. Well, first of all, I know everything is going to get shifted to the left 2 pi. The period is going to lengthen because the normal period is pi, but our period is 2 pi. And also, what else happens? Everything went up 2 units, and the y values got multiplied by 4. The y values got quadrupled. So that's going to affect these two. Remember how these two ordered pairs are 1 away? They have a vertical change of 1 from the center. Now, our new function is going to have a vertical change of 4 from the center. Okay. All right, let's do this. Let's graph this. All right, thinking ahead, knowing that my midline is 2. So I want to have 2 somewhere in the center. I know I went to the left 2 pi. So I'm just going to draw, I'll make that 2 pi to the left. And here's 4 pi, we got 0 and 2 pi. And 1, 2, 3, 4, 5, 6. So I'm going to draw my midline and my vertical asymptotes. I found the 2 by looking at that inequality right there. So negative 2 pi is 1 vertical. The next one is at 0. I mean, everything thereafter is 2 pi away, the period, because the period is 2 pi. So I'm just going to draw 4 of them. And at the midline, in between the 2 asymptotes, and this is also true for a tangent, the graph is going to cross the midline right in between those 2 vertical asymptotes. And tangent is, cotangent is the one that goes down. So I have to remember that from the middle, looking right there, a quarter of the period to the left and to the right, I am changing by 4. Usually I would change by 1, but that vertical stretch changes everything, it quadruples everything. So instead of going over a quarter of a period and up 1, I'm going to go over a quarter of a period and up 4. That's that vertical stretch. And I'm going to go to the right a quarter of a period and down 4. Again, the vertical stretch. And that enables me to graph pretty accurately what this is going to look like. I think if you're following along, if you do if you graph these by hand, it's easier. It's much easier to go backwards. If you're not really kind of participating now, then when you try to go backwards, it's really difficult. So I want to get to the point where I give you this red graph, and you can come up with something like this. Let's identify some key points. We'll identify the first 3 that I found, these 3. So that one way over to the left, well, this is negative 3 pi. So the one halfway between negative 3 pi and negative 4 pi is negative 3.5 pi, which is 7 halves. Negative 7 halves pi. And the y value is positive 6. The ordered pair that's right in the middle is at negative 3 pi, comma 2. And the one on the right is in between negative 2 pi and negative 3 pi. So that's negative 2.5 pi, which is 5 halves. 2.5 is 5 halves, right? Negative 2. And then this is worth mentioning again. Notice 2, the y value 2 is the midline. Look at these other 2. They're both 4 away from the midline. If you add 4, you get 6. If you subtract 4, you get negative 2. That should be an indicator that you're on the right on the right path because everything got quadrupled. Vertical asymptotes. Well, they occur at x equals negative 4 pi, x equals negative 2 pi, x equals 0, and on and on and on and on and on. So in general, any amount, so that's n, of a 2 pi, that will account for all possible vertical asymptotes.